Deputy Executive Information Engineers in Andhra Pradesh Information Services, Electronics and Communication Engineering 2019 Question Paper Solutions Part 5, that is from question number 121 to question number 150. Question number 121. The Z transform of a signal minus a power n u of minus n minus 1 is, the given signal is left-sided signal, anti-causal signal. The Z transform of minus a power n u of minus n minus 1 is z by z minus a for mod z less than a. The region of convergence is mod z less than a. Similarly, for causal signal or right-handed signal, the Z transform is z by z minus a, but the region of convergence is mod z greater than a. The correct answer is option 3, z by z minus a. Next question. Radar is acronym for radio detection and ranging. Radar stands for radio detection and ranging. It is a system that uses radio waves to detect and determine the distance, direction, and velocity of objects. These radars are used to detect the distance, direction, and velocity of objects. Radars are used in various applications including weather forecasting, air traffic control, and navigation, etc. Correct answer is option 4, radio detection and ranging. Question number 123. Identify the wrong component in optical transmitter. Let us see the block diagram of optical fiber communication system. It consists of analog to digital interface, voltage to current converter, light source, source to fiber interface, and then optical fiber is a channel or medium. This optical fiber is medium for transmitting the signals, and then at the receiver side, fiber to light detector interface, photo detector, current to voltage converter, and then analog to digital interface, analog or digital interface. So from the transmitter section, optical source is present, modulator is present, channel coupler is present, the photo detector is related to receiver. Therefore, correct answer is option 2. Photo detector is a wrong component in optical transmitter. Question number 124. A telephone exchange has 9,000 subscribers. If the number of calls originating at peak time is 10,000 in 1 hour, the calling rate is given. Total number of subscribers is 9,000 and the total number of calls originating at peak time is 10,000 per hour. Calling rate is number of calls per subscriber, that is total number of calls to total number of subscribers. Total number of calls is 10,000 per hour and total number of subscribers is 9,000. Correct answer is 10 by 9. Its value is 1.11. Therefore, option 2 is a correct answer. Question number 125. The process is to arrange the atom in single crystal fashion upon the single crystal substrate is, it is epitaxial growth. Epi means upon, taxis means order. Epitaxy is a method of growing crystalline layer on a crystalline substrate, growing a crystalline layer on a crystalline substrate, where layer mimics the crystal orientation of substrate. Again, this epitaxy is of two types, homoepitaxy and heteroepitaxy. This epitaxy is a process used to grow a thin crystalline layer on a crystal substrate. In this process, substrate wafer acts as a seed crystal. Correct answer is option 1. Next question. In 555 timer, a stable mode of operation, the fundamental frequency of output waveform is, for a stable mode of operation of in a 555 timer, output frequency is 0.693 RA plus 2RB into C. Correct answer is option 4. These are diagram for a stable multi-vibrator using 555 timer, where charging time constant is 0.693 RA plus RB into C, and discharging time constant is TD is 0.693 RB into C. Therefore, total time is charging time constant as well as discharging time constant. Sum of charging and discharging time constant TC plus TD, that is 0.693 RA plus 2RB into C. Correct answer is option 4. Question number 127. The method of selecting one or two parameters using the root locus method is called. So none of the options are correct here, and this question is deleted from the question paper. The method of selecting one or two parameters using the root locus method is called root contour method. It is called root contour method or multivariable root locus method. This technique extends the traditional root locus approach to analyze the systems with multiple adjustable parameters by varying one parameter at a time while keeping the others fixed, or by varying two parameters simultaneously to observe their combined effect on the system stability and performance. The method of selecting one or two parameters using root locus method is called multivariable root locus method or root contour method. Here none of the options are correct, and this question is deleted from the question paper. Next question. The intrinsic impedance for partially medium is. Here the question is not clearly asked. So we know the formula. The intrinsic impedance of a medium is given as eta is equal to under root j omega mu by sigma plus j omega epsilon. For good dielectric material where sigma by omega epsilon far less than 1, intrinsic impedance is given as eta is equal to mu by epsilon. Similarly, for good conductor where sigma by omega epsilon far greater than 1, intrinsic impedance is given as under root omega mu by sigma at an angle of 45 degrees. Similarly, for free space, sigma is 0, conductivity is 0, intrinsic impedance is given as eta is equal to eta naught under root mu naught by epsilon naught, that is its value is 120 pi, that is 377 ohms. So the correct answer from the given options is option 3, that is under root j omega mu by sigma plus j omega epsilon. Option 3. Next question. Consider a discrete time LTI system described by the equation y of n minus 1 by 2 is equal to x of n plus x of n minus 1 by 2. The frequency response of the system is. So given discrete time linear time invariant system, discrete time LTI system, and this system is described as y of n minus 1 by 2 y of n minus 1 is equal to x of n plus 1 by 2 x of n minus 1. Apply discrete Fourier transform on both sides. Discrete Fourier transform on both sides. We will get y of n is replaced with y of e power j omega minus 1 by 2 e power minus j omega y of e power j omega is equal to x of e power j omega for x of n, and 1 plus 1 by 2 x of e power j omega into e power minus j omega. And rearrange this expression, we will have h of e power j omega, that is discrete time transfer function, is equal to the ratio of output to input response y of e power j omega to x of e power j omega. So we will get 1 plus 1 by 2 e power minus j omega by 1 minus 1 by 2 e power minus j omega. This is a note. Time shifting property, x of n minus n naught is e power minus j omega n naught into x of e power j omega. Using this time shifting property, we need to solve this question. The correct answer is option 4. Simply apply Laplace transform and find the ratio of output to input. Simply apply discrete time Fourier transform and find the ratio of output to input. Next question. Question number 130. A binary ripple counter is capable of counting the number of items passing on a conveyor belt each time an item passes a given point. A pulse is generated that can be used as a clock input. If maximum number of items to be counted is 8000, number of flip-flops required is given. Total number of counts is 8000 counts and we need to calculate the total number of flip-flops. The number of flip-flops required is greater than or equal to log n base 2, and this is a formula to calculate the number of flip-flops. So substitute log of 8000 base 2, its value is 12.96. Therefore number of flip-flops required n is 13 flip-flops. So 13 flip-flops are required to calculate 8000 pulses. Correct answer is option 4. Question number 131. Lead compensator has a pole 2. So in the image, lead compensator and lag compensator is represented. This lead compensator has a pole to the left of 0. Lead compensator has a pole to the left side of the 0, whereas lag compensator has a 0 to the left of the pole. Correct answer is option 1. Lead compensator has pole to the left of the 0, left hand side of the 0. Question number 132. A system has a characteristic equation of s cube plus 10s square plus 2s plus 30 is equal to 0. Then the system is. So given characteristic equation is given, we need to calculate the nature of the system. Given characteristic equation by s cube plus 10s square plus 2s plus 30 is equal to 0, by using RH criterion, Routh-Hurwitz criterion, we need to calculate the number of sign changes. Here s cube coefficients are 1 and 2 and s square coefficients are 10 and 30, and the coefficient of s power 1 is minus 1 and for s power 0 it is 30. There are two sign changes from s square to s1 and from s1 to s0. So there are two sign changes. It means there are two roots on the right hand side of the s plane. Two sign changes in the first column of RH array. Two roots lie in the right hand side of the s plane. Therefore the system is, nature of the system is unstable. It is an unstable system. Next question. The skin depth at a frequency of 1.6 megahertz in aluminum is dash. Given frequency is 1.6 into 10 power 6 hertz and the conductivity of aluminum is 38.2 mega Siemens per meter, and relative permeability that is mu r is equal to 1. Skin depth delta is, the formula for skin depth delta is 1 by square root of pi f mu sigma. Substitute the values here. Under root frequency pi value is 3.1417 and frequency f is 1.6 into 10 power 6, mu is 4 pi into 10 power minus 7, because we know mu is equal to mu naught into mu r. In the question mu r is 1, therefore mu is equal to mu naught, and the value of mu naught is 4 pi into 10 power minus 7. 4 pi into 10 power minus 7, and conductivity 38.2 into 10 power 6. On substitution we will get delta is equal to 1 by 15.533 into 10 cube, that is 64.37 micrometer. Therefore skin depth delta is equal to 64.37. Correct answer is option 1. Question number 134. The impulse response of the systems are given by h1 of t is equal to e power minus 2t, h2 of t is equal to 2 e power minus t u of t. These two systems h1 of t and h2 of t are connected in cascade. Then impulse response of overall system is. So given the impulse response of system 1 h1 of t is e power minus 2t u of t, and impulse response of system 2 h2 of t is 2 e power minus t u of t. Find the transfer function of first system. H1 of s is Laplace transform of impulse response h1 of t, that is Laplace transform of e power minus 2t u of t. So it is 1 by s plus 2. Similarly, transfer function of second system, Laplace transform of 2 e power minus t u of t is 2 by s plus 1. Then we need to calculate the overall transfer function if these two systems are connected in cascade. When two systems are connected in cascade, the overall transfer function is product of individual transfer functions. 1 by s plus 2 into 2 by s plus 1. So arrange this, minus 2 by s plus 2 plus 2 by s plus 1. So this is the overall transfer function. So apply inverse Laplace transform, that is overall transfer function h of t is equal to inverse Laplace transform of h of s. Inverse Laplace transform of h of s. Now inverse Laplace transform of minus 2 by s plus 2 plus 2 by s plus 1. So we will get 2 into e power minus t minus e power 2t u of t. Correct answer is option 1. A note point is mentioned here. If two systems h1 of t and h2 of t are connected in cascade, then overall impulse response is h of t is h1 of t convolution h2 of t, or h of s is h1 of s into h2 of s. Convolution in time domain is multiplication in frequency domain. Next question. A two-port network is known to have the following scattering matrix. If the port 2 is terminated with a matched load, then return loss seen at the port 1 is. These are the note points. We know that insertion loss IL is minus 20 log 10 S21, and voltage standing wave ratio at port 1 VSWR 1 is 1 plus modulus of S11 by 1 minus S11. Similarly, voltage standing wave ratio at port 2 is at output port 1 plus S22 by 1 minus S22, and voltage reflection coefficient at input port is S11, voltage reflection coefficient at output port is S22, and input return loss is 20 log 10 modulus S11 dB, and output return loss is 20 log 10 modulus S22 dB. The magnitude. In the question, they have asked return loss seen at port 1. So that is input return loss. So return loss seen at port 1 or input return loss is 20 log S11 modulus 20 log modulus S11 dB. That is 20 log 10 modulus of S11, that is 0.15 at an angle 0 whole modulus dB. And its value is minus of 16.478, that is 16.6 minus modulus of minus 16.478 dB, that is 16.478 dB. Correct answer is option 1. Next question. An 8-bit binary ripple up counter with modulus of 256 is holding the count 0, 111, 4 ones. what will be the count after 135 clock pulses? In the question it has been mentioned it is an 8-bit ripple up counter with modulus of 256. Ripple up counter with modulus of 256. For a ripple up counter, the state starts from 00000000, all zeros to all 1. When it reaches to all 1, again it resets to initial states. Given count is 0111111, its value is 127. Now the initial count is 127. After 135 clock pulses, it completes 256 from 127 to from 127 after 135 clock pulses it completes 256 counts plus 6 counts in the next cycle. Therefore the state of the counter is 6 000001110. The correct answer is option 2. Question number 137. A zero mean white noise is passed through a ideal low pass filter of bandwidth 10 kHz. So given the input is zero mean white noise and it is passed through a low pass filter with a bandwidth of 10 kHz. So that means for low pass filter bandwidth is 10 kHz means the highest frequency it is passing is maximum frequency it is allowing is 10 kHz. Also given the sampling time period is 0.03 millisecond per sample. So sampling time period is 0.03 milliseconds, that is 30 microseconds. Using this sampling time period, calculate sampling frequency Fs is equal to 1 by Ts and its value is 33.33 kilohertz. Now by using Nyquist criterion, we know the sampling frequency should be greater than or equal to 2 times of highest frequency component Fm. Here highest frequency component of message signal is 10 kilohertz, 2 Fm, that is Nyquist criterion is Nyquist sampling frequency is 20 kilohertz. So here actual sampling is 33.33. Therefore Nyquist criterion is satisfied. Sampling frequency is greater than 2 times of message signal frequency. Nyquist criterion is satisfied. If Nyquist criterion is satisfied, then there is no aliasing. The continuous time filtered noise is widespread stationary and band limited. Therefore after sampling we will have discrete time widespread stationary random process with zero mean, correlated samples and Gaussian if the original white noise is Gaussian. Therefore correct answer is option 3. The samples are correlated with each other. See the note point. White noise has constant power spectral density over all frequencies. White noise has zero mean and uncorrelated in time. When this uncorrelated white noise is passed through a ideal low pass filter with sampling frequency greater than the Nyquist state, then the samples are correlated with each other. Correct answer is option 3. Question number 138. The magnitude of closed loop response is reduced approximately to 1/4 of the maximum value in one oscillatory period. This definition belongs to, it is logarithmic decrement. The measure of how the amplitude decays in damped oscillation system, specifically referring to the rate of exponential decay between successive peaks in second order system, is logarithmic decrement. Here none of the options are correct and the question is deleted. The definition in the image refers to damping ratio or more specifically to logarithmic decrement in control system and vibration analysis. Next question. A class A amplifier delivers 5 watt to the load with an input signal of 100 milliwatts. The power gain is, here the output power is 5 watt and the input power given is 1000 milliwatt. Power gain is, it's a ratio of output power to input power. So output power is 5 and input power is 100 milli, 10 power minus 3. The power gain is 50. Correct answer is option 2. Next question number 140. The minimum and maximum for the Boolean function f of abc is pi of 037. Here maximums given are 037 and the minterms are 1, 2, 4, 5, 6. Using k maps, we need to calculate the minterm expression, that is f of a comma b comma c is, for k maps find the pairs. These two ones form a pair, these two ones form a pair, and again these two ones form a pair. For 3 pairs, the corresponding minterms are AB bar plus B bar C plus B C bar. Similarly, for max terms, only one pair exists, and this is an isolated max term. And the corresponding expression is f of a comma b comma c, that is pi of 037 is equal to a plus b plus c into b bar plus c bar. Correct answer is option 2. Next question. A 100 stage serial input serial output shift register is clocked at 100 kilohertz. How long will be the data be delayed in passing through the register? Given serial input serial output shift register, here the number of stages mentioned is 100, number of stages small n is 100, and the clock frequency is 100 kilohertz. Now the total time period is n into t clock. The total time period is n into t clock for serial input serial output shift register, that is n value is 100 and the clock time period is 1 by frequency of clock, 1 by 100 into 10 cube, so that is 1 millisecond. Correct answer is option 2. Next question. Which statement is correct for envelope detector? For envelope detection, mu is less than 1, 0 less than mu less than 1, that modulation index should be less than 1, and 1 by frequency of carrier signal far less than RLC, discharging time constant far less than 1 by the frequency of message signal. Similarly, discharging time constant RLC less than or equal to 1 by 2 pi fm square root of 1 minus mu square by mu. These are the 3 conditions that has to be satisfied for proper envelope detection. So carrier frequency is large compared to message bandwidth. The correct answer is option 4. The carrier frequency is very large. It is slightly larger than message bandwidth. This is incorrect. Percentage modulation index is less than 100%. It is not exactly. And percentage modulation index of AM wave is less than 50%. It is not 50%. It is less than 100%. Therefore, correct answer is option 4. Next question. A 6-bit ladder digital to analog converter has input of 101001. If bit 1 represents 10 volts and bit 2 represents 0 volts, the output is, given 6-bit ladder digital to analog converter, and the input is 101001, that is B5, B4, B3, B2, B1 and B0. For logic 1 they have mentioned 10 volts and for logic 0 they have given 0 volts. And the output of digital to analog converter V0 is Vfs by 2 power n minus 1 sigma I is equal to 0 to n minus 1 Bi 2 power I. This is the formula used to calculate the output voltage of analog to digital to analog converter. So here full scale voltage is 10 volts and the number of bits is 6, 2 power 6 minus 1, 2 power 0 plus 2 cube plus 2 power 5. Its value is 6.5 volts. Correct answer is option 1. Given that IC7483 is a 4-bit parallel adder chip, how do you build a 16-bit parallel adder chip? In the question, it has been mentioned that IC7483 IC7483 is 4-bit parallel adder chip. To create a 16-bit adder using 4-bit 7483 chips, we need to use 4 quantity of 7483 chips. Cascade carry outputs to the next carry input. Starting with carry input is 0. That is by cascading the arrangement of 4 IC7483 chips, we will get 16-bit parallel adder circuit. Correct answer is option 4. Next question. When the channel is noisy, producing a conditional probability of error 0.5, the channel capacity and entropy function will be dash and dash respectively. When the channel is noisy and the conditional probability of error is 0.5, it corresponds to the worst case scenario, that is completely noisy binary symmetric channel. In this case, channel capacity is 0 because no information can be reliably transmitted, and the entropy function is 1, indicating maximum uncertainty. Entropy is 1, indicating maximum uncertainty, and channel capacity is 0 because no information is reliably transmitted. Correct answer is option 3, 0 and 1. Capacity is 0, no information is transmitted, and entropy is 1, maximum uncertainty. Correct answer option 3. Next question. Question number 146. The major difference between the rectangular and cylindrical waveguides as power transmitters when each operates in its dominant mode is. The major difference between rectangular and cylindrical waveguides as power transmitters when each operates in its dominant mode is geometrical factor. Geometrical factor is a major difference. Correct answer is option 3. And this geometrical factor affects parameters like power handling capability, field distribution, and attenuation. In waveguides, rectangular waveguides typically operate at TE10 mode, whereas cylindrical waveguides operate at TE11 mode. This geometry directly influences how efficiently the waveguide transmit powers, the cutoff frequency, and mode behavior. Correct answer is geometrical factor, which decides the power handling capability, field distribution, attenuation, mode behavior, cutoff frequency, and waveguide transmit power. Question number 147. Non-coherent detection is not possible in phase shift keying because in PSK information itself is contained in the phase. Hence, non-coherent detection is not possible. In amplitude shift keying, frequency shift keying, non-coherent detection is possible. In ASK, it can be detected non-coherently by envelope detection. Frequency shift keying can be detected by non-coherently by using frequency discriminators or energy discriminators, whereas in PSK, non-coherent detection is not possible. Similarly, in DPSK, non-coherent detection is possible. Question number 148. The single mode fiber support only dash mode. Single mode fiber supports only HE11 mode. HE11 mode, also referred as fundamental mode or single mode or monomode fiber. Fundamental mode or single mode or monomode fiber that supports only the lowest order HE11 mode, also known as fundamental mode of the step index fiber. Single mode fiber supports only fundamental hybrid mode HE11. This hybrid mode contains both electric components and magnetic field components, in longitudinal and transverse directions. Correct answer is option 2. So TE01 transverse electric, HE01 hybrid mode, TE11 transverse electric. And the fundamental mode is HE11. Hybrid mode is HE11. Next question. The Nyquist rate for signal x of t is omega s. The Nyquist rate for d by dt of x of t. We know that the differentiation, integration and time shifting convolution has no effect on Nyquist rate. Therefore, the Nyquist rate remains same. Here the differentiation is given that once the signal is differentiated, its Nyquist rate doesn't change. Once the signal is integrated, Nyquist rate doesn't change. If signal is time shifted, Nyquist rate doesn't change. Because of convolution, Nyquist rate doesn't change. So Nyquist rate remains omega s. Question number 150. Last question. For a plastic fiber, refractive index of core is 1.6 and refractive index of cladding is 1.49. The numerical aperture is equal to, given refractive index of core is 1.6 and refractive index of cladding is 1.49, and they are asking to calculate the numerical aperture. Numerical aperture is under root of n1 square minus n2 square. This is a formula. Substitute the values here. Under root of 1.6 whole square minus 1.49 whole square. On substitution, we will have its value is under root of 0.3399, that is 0.583. Correct answer is option 4, 0.58.